Imagine standing at the edge of San Francisco Bay in the early 1930s. But nearly 3 miles of open water separated the two shores, with powerful currents, heavy fog, strong winds, and difficult underwater geology. Engineers faced a massive challenge: build a suspension bridge across one of the most difficult waterways in America. The planned bridge would have a 4,200-foot main span, stretching between two enormous towers. How could workers build foundations in the water, towers above the ocean, cables in midair, and a roadway seemingly suspended over nothing? Between 1933 and 1937, thousands of workers would transform that impossible idea into reality. Before construction could begin, engineers first had to determine what kind of bridge could survive the Golden Gate. Strauss developed the project while working with engineers and specialists on the final structural design. The final design became a suspension bridge supported by 2 enormous towers and 2 main cables. Vertical suspender ropes would hang from the main cables and support the roadway beneath them.
The completed bridge would stretch about 8,981 feet, with a 4,200-foot main span.
But engineering wasn't the only obstacle. America was deep in the Great Depression, making financing extremely difficult. Major portions of the bridge were divided among different construction companies and specialized contractors. On January 5, 1933, construction officially began. The first major task was not building the towers. It was creating the foundations beneath them. At both ends of the bridge, workers excavated huge areas of land for enormous concrete anchorages.
Okay, lift it slowly now. Watch the clearance. Steady, steady. All right, set it down easy. All right, set it down easy.
The main cables would pull outward, creating enormous tension that had to be safely transferred into the ground. Each completed anchorage would weigh approximately 60,000 tons, acting like a gigantic buried weight. On the marine side, workers began constructing the first major tower pier in January 1933. By June 1933, the Marin Pier had been completed and was ready to support the tower. The San Francisco Tower Foundation was much more difficult because it had to be built far out in the Golden Gate Strait. Engineers built an enormous construction trestle, extending approximately 1,100 feet offshore. The trestle became a temporary working highway into the middle of the Golden Gate. On August 14, 1933, a steamship traveling through thick fog crashed into the construction trestle. Then, in December, a powerful southwest gale battered the trestle again.
Section 4 Alpha is completely compromised. The steel joints are sheared. Confirmed. We show major splintering on the lower supports as well.
Engineers eventually completed a massive protective fender around the future San Francisco Tower Foundation. Inside the protective enclosure, workers created an enormous dry construction area by pumping water out. Approximately 9.41 million gallons of water were pumped from the foundation area. By 1935, the San Francisco Tower Foundation was ready for the enormous steel tower above it. Now the project entered a new phase, assembling tens of thousands of tons of structural steel. Tower steel fabricated in Pennsylvania was transported across the country and shipped toward the Bay Area. At the Golden Gate, workers assembled the tower sections piece by piece. Each connection had to be aligned precisely and secured with thousands of hot rivets. Workers climbed hundreds of feet above the water while handling enormous steel components. By 1935, both towers were approaching completion and ready for the suspension cables. By 1935, both towers were approaching completion and ready for the suspension cables.
The sheer weight of this coil. And that's just the start. We follow the diagram, one strand at a time until it reaches the top.
Temporary footwalks were constructed between the towers to allow workers to work high above the water. In 1935, crews installed the first wire cables needed to support the catwalk system. The main cables were built in place using a process called aerial cable spinning. A single steel wire was pulled from one anchorage over both towers and to the opposite anchorage. Then the system sent the wire back again, repeating the journey thousands of times. Each main cable would eventually contain 27,572 individual galvanized steel wires. Across both main cables, approximately 80,000 miles of galvanized steel wire were used. The cable spinning operation continued for approximately 6 months and 9 days. After spinning, the enormous wire bundles had to be compressed into their final circular cable shape. By 1936, the two enormous main cables had become the bridge's primary suspension system. Next came the vertical suspender ropes, connecting the main cables to the roadway. The roadway's weight would travel through the suspenders into the main cables, towers, anchorages, and ground. Now workers had to transform the suspended cable system into an actual roadway.
Massive steel roadway sections were fabricated, transported to the site, and brought toward the span by barge.
Hold the line! Steady now! Ease the tension on the east side. Coming around! Watch your feet!
Workers progressively built outward from the towers, adding steel section after steel section. One crew worked from San Francisco, while another worked outward from Marin. Piece by piece, the enormous gap between the two sides became smaller. In November 1936, after years of work, the two sides of the main span finally approached one another. The final steel sections were connected near the center of the span. On the marine side, roads were built to connect the bridge toward Sausalito. The San Francisco approach also included the dramatic Fort Point Arch beneath the bridge. Building the bridge was extraordinarily dangerous, with workers hundreds of feet above water and exposed to powerful winds. Chief Engineer Joseph Strauss insisted on unusually strict safety measures throughout the project. Workers used hard hats, safety lines, protective goggles, and specialized equipment designed for the difficult environment. One of the project's most famous innovations was a massive safety net suspended beneath the roadway. The net provided workers with a last line of protection while they worked above the water. On February 17, 1937, a catastrophic scaffolding accident claimed the lives of 10 workers.
By early 1937, The basic suspended structure was complete, and workers focused on finishing the roadway.
The steel skeleton was gradually transformed into a functioning highway deck.
Paving crews completed the roadway, with paving work finished on April 19, 1937.
By late April 1937, the bridge was almost complete, and a final ceremonial rivet marked the achievement.
Edward Iron Horse was selected to drive the famous final ceremonial golden rivet.
Well, that didn't quite go as planned.
Look at that mess, it completely shattered.
The finished bridge stretched approximately 1.7 miles from abutment to abutment, including approaches. Its main suspension span stretched 4,200 feet between the two towers. The towers rose 746 feet above the water, dominating the Golden Gate skyline. The original structure used approximately 389,000 cubic yards of concrete and 83,000 tons of structural steel. Before opening, engineers inspected the towers, cables, suspenders, roadway, approaches, electrical systems, and safety equipment.
On May 27, 1937, the Golden Gate Bridge opened to pedestrians.
Hundreds of thousands of people came to experience the new bridge during the pedestrian opening.
The following day, May 28, the Golden Gate Bridge officially opened to vehicular traffic. Cars began crossing the bridge, transforming the impossible construction project into a working transportation link.
First, engineers surveyed the site and developed the suspension bridge design.
Second, the Golden Gate Bridge and Highway District secured financing and construction contracts.
Third, construction officially began on January 5, 1933.
Fourth, workers excavated and constructed enormous land-based anchorages. Fifth, workers constructed the Marin Tower Pier.
Sixth, engineers built the massive offshore trestle and protective fender system.
Steady flow on the concrete. Make sure the vibrator hits that corner. Roger that. Looks good here.
Eighth, the enormous steel towers were assembled piece by piece.
Ninth, temporary catwalks were installed between the towers. 10th, thousands of individual steel wires were repeatedly spun across the span.
12th, vertical suspender ropes were attached to the main cables. 14th, the two sides of the suspended structure met in the center. 15th, approach roads and structures were completed on both sides of the bridge.
16th, the roadway deck was completed and paved. 17th, safety systems, electrical systems, and finishing work were completed.
18th, the ceremonial final rivet was driven, marking the completion of the structure. The Golden Gate Bridge wasn't created by simply placing two towers in the water and hanging a road between them.
The foundations had to support the towers, and the towers had to support the main cables. And the entire structure had to survive wind, currents, traffic, earthquakes, and the harsh Golden Gate environment. Thousands of workers, engineers, machines, mathematics, materials, and determination had finally solved the impossible problem. The cables supported the suspenders, and the suspenders supported the roadway. This was how the Golden Gate Bridge was built.
It didn't simply connect San Francisco and Marin County. It demonstrated what human engineering could accomplish.
This was how one of the world's most famous bridges went from an impossible dream to reality.